Good afternoon. Gotta be careful here because typically, or in the past, I used to do this stream in my morning, which was, what was the time? 9:30, 10:30, something like that. But now I switched this to the early afternoon. So it's 2:30 p.m. here, Central European summertime. I'm Renee, and well, why am I doing this stream? First of all, because it gives me motivation to work on my code here. It gives me a reason to do that. And second, well, I think what I do here all around Azure C#.NET is potentially interesting to some folks out there. So that's why you find me here. What we're looking at here is a multi-episode stream. I'm working on a project that I simply called Dashboard, and you can find the previous episodes. This is number 6 today. You can find the previous ones here on Twitch, or you can find them recorded and uploaded to YouTube. The link to the project, or the entry point to the project, is a Github repository, and I want to put the link here into the chat window. So that's it. It's github.com/krumelur/dashboard. And if you open that up and look at the README, you'll find that, well, here's the link to Twitch. Here's the link to the YouTube playlist where I have uploaded all the previous sessions to. So that means for a detailed intro about this project, please go back to episode number 1. However, with every episode, I quickly wrap up what this is about, so it's no different today. This project is called Dashboard, and the idea is that I want to build a dashboard. Who would have guessed? More or less a simple static website that gets, or web page really, just one page that gets regenerated whenever certain events occur. And that website is supposed to show data about, well, various sources that I tend to check at least once a day or even multiple times a day. So what are these sources? Well, number one, I want to know what is the workout of the day in my gym. So to do that, I typically go to the website and I navigate the menu and I read what is going on there. Then I want to know how much energy are my solar panels delivering. So I open up an app on my phone and I check what's going on there. So that's the second one. Then I often want to know what's happening with the central heating unit. This is wood pellets powered. I want to know how many supplies are left there. Now to do that, I would have to run down to the basement and check there. There's a little monitor. So I got to check that, and if necessary, got to order new ones. And then finally, there's the car. It's an EV, and I want to know, well, what's the state of charge there? And then I can maybe decide, well, if the solar panels deliver enough energy, maybe I want to start charging the car. Things like that. And I want to see these things at one glance instead of using 4 different apps or 4 different websites. And I thought maybe I can add other sources over time. We could think about a source that shows the weather. So I imagine it's going to look something like this down here. It's just a screen with different boxes and it shows basic information about the sources. I mean, it can always be improved to show graphics and whatnot. But for now, that's the plan. So to do that, I started implementing a Visual Studio or C# solution, a .NET solution, which is all based on .NET Core and Azure. That's the plan. So the idea is that there's one main function or one piece of code that in intervals looks at the different sources, pulls data from these sources and stores them into a history table. And well, the code that runs this, that's going to be an Azure function, a durable function. All the sources that I've implemented so far, that's here in the stream, the solar and the workout of the day, they are regular Azure functions. Today I want to look at the one that gets data from the car. And in the previous episode, I also did this one here, which is not a function, which is running inside a Docker container. So you see, it's a mixture of technologies, functions, containers, .NET Core. I want to look at today at the Azure Portal and maybe at the Azure Cosmos DB table storage and their APIs, and eventually look into storage blobs so I can host a static site. That's the plan. Now with that, I'll switch here to Visual Studio and I'll just close all documents because I found something out that I quickly want to bring up here. In the previous episode of the stream, I really, for the first time, I created a Docker container, and that Docker container was for, or is for, the client application that gets the amount of supplies from my central heating unit. So quickly recapping that story, the central heating unit can be connected to the local network in my home, and it has got a web interface, and it's also got an API that you can call, and that returns XML. So I cannot reach that from the internet, so it has to run inside my own network, and whatever this client application retrieves should then be uploaded to Azure and go into the history there. And I thought I probably want to run this on something like a Raspberry, and instead of running the .NET application directly there, I thought maybe just containerize it, so I know if the container is working on my machine here, I can deploy it to the Raspberry and it will just do its job there. And really, I haven't done anything with containers before. So last time I showed how I created that. Really, it's a console application. You see, there's nothing special in here. It's just a console app. I created that, and I manually created a container out of it. So I added a container file here, and then I even created and ran the container over on the Mac. So here, because that's where I had Docker installed. And the problem was that over here on Windows, I was unable to run the container because that Windows is a virtual machine. And in order to run containers in Windows, you would need another virtual machine. And you cannot easily run a virtual machine inside a virtual machine. At least Parallels Desktop does not allow that. So while that manual approach worked, I upgraded a bit. That means I was willing to pay for the Pro version of Parallels Desktop, and that Pro version supports nested virtualization. So with that, I am now able to run Docker in here. I can, actually it's already running. If I look in here, there's Docker Desktop is running. So now I have got Docker on Windows. And that then brought me to the next question. Well, isn't there a more integrated way in Visual Studio to run an application inside a container? A little bit of testing, and with .NET Web Applications, it's easy. You can, when you create a project, file new project, you can select Web, ASP.NET Core, MVC, and you just tick the checkbox, yes, I want container support. But that does not exist for console apps. However, it's so easy that it's almost too easy. So I want to show you that, because that frees me from the manual approach from the manual way of creating this container. So you can right click on a project here, and if you go to add, there is Docker support. So let's try that and see what happens. Go for Docker, because the target OS, yeah, that's going to be some Linux. And then it says, yeah, there already is a Docker file. You want to generate a new one? And I'm like, yeah, sure, let's just do that. Let Visual Studio do its magic. And what happens is that it renamed my Docker file to Docker file original, and it created a new one. Now, if I compare these two, I want to see what is in there. So that's something that I haven't done. So apparently the one that Visual Studio creates has a lot more content. What are they using as a base image? I'm using .NET Core Runtime 2.2. This is using .NET Core Runtime 2.2. Stretch Slim. Whatever. Stretch Slim. I don't know. Maybe that's an even smaller base image. I did not think that this was really a big application that resulted here in creating that container. But anyway, what is it doing then? It's then, well, I'm just copying the app over the binary. Yeah, because I did that manually. So what is this puppy doing here? It copies over the client project. It copies over the support library that I'm using. It copies over, yeah, it copies over all the reference projects apparently. It then restores the client that recursively would restore everything that the other projects need. Copies everything. Ah, that's interesting. So this is then also, this is building it. Is it? This is, yeah, this is building it in the container, which is different from what I did. I built it on Windows and then I created the container on the Mac, which also works, but this is building it in the container. It then removes the source code, build it up, and publishes. So that's all the steps in one Docker file and all automated by Visual Studio. So I think that's a lot better than what I did here. So let's give that a try. The other thing is up here, it has now changed to say Docker. So originally it just said ETA client. That was my console app. I should still be able to run that. Let's give that a try. I don't think it needs any parameters, does it? Yeah, I wanted to do this with parameters, but I can do this later. So this app is talking to the central heating now, starting to pull. And that's it. Yeah, there we go. So 1150. So that's working. However, I can also run this containerized now, or I should. I haven't tried it. So let's switch to Docker here. Fire this up. And now it's supposed to run the very same application, but inside a container, which is of course super convenient because it saves you from going through all these manual steps of creating the container. So let's see what happens. Any output? Oh. Where's that? There, containers. There it is. So there's the Dazzling Murdoch. Silly container names. And it's running that inside the container now. So that's of course, yeah, it's really convenient. I can debug that, and I bet I could also publish that now. What happens if I publish this now? Folder profile? No, not really. Anyway, I don't know, but the thing is, I've got my container now. I can create it directly here in Visual Studio, and I was just hoping for it to offer now to deploy that to, I don't know, Azure Container Instances or something, but it doesn't. Let's have a look at that. Dashboard, ETA, client, binary, release. Hey, I got to read more about that, it seems. I don't know how to get that container now, or how to do something with it, because it seems like it, oops, where's my mouse? It seems like it attached it here. So let me see. If we look at Kitematic, come on, load it. There's the Dazzling Murdoch. There it is. And the core app image, which is a layer below. But how would I publish that? I don't know. I got to read more about this. Anyway, so this is just one thing that I discovered, and I wanted to improve the solution, so this is included. Now, the other thing that I talked about last week was the, where is it here? Nah, yeah, kind of this one here. The EV, the car. So I said I was going to implement that kind of offline. I didn't want to do this live on the stream because it involves handling my very sensitive data, like my username and my password and client secrets and whatnot. And whenever I handled or whenever I did something with access keys or passwords, I managed to disclose them on the stream, which hasn't been a big thing so far because I could just change or rotate them. But yeah, if you get access to my car, that would just be bad. So I wanted to avoid that. And so what I ended up doing is just add the project, and I think I'm just gonna walk through this because it may be interesting how this works. So here's the thing. I added another source, which I called source EV. So the sources, those are those functions that I have, those Azure functions. One for every source. So there's one for the workout of the day, one for Solar, and now there's one for EV. So here's what it's doing. So these are the things that it needs. You see the EV, it's a Tesla, and it's not so much of a secret that they have got an API. It's not really public, but if you, how to phrase it, if you know where to look, it's not a big problem to get access to it. The things that you need are a client ID, a client secret, you need your username, you need your password. So these two are kind of obvious. That's what you have from your Tesla account. But the other two, yeah, you can find them. And there are projects out there that document the API. So Tesla themselves, they don't document it, but I mean, it's a web API, so we could use that. So here's what I created. I wrote myself a little class that I called native Tesla API because it's the lowest layer that allows me to communicate with their services. I was planning to abstract that a bit. And it requires to be initialized with the client ID, the client secret, and the dashboard here, that's a user agent that it's using. And then you could do things like log in asynchronously, get all the vehicles under that account, find the first vehicle, and then eventually get information about the state of charge, or I mean, you can even do crazy things like unlock the car. And you see why I want to be careful to not disclose these things here. I don't want to find my car blinking and honking suddenly outside. So it's not that difficult to do this. As in the previous ones, I'm using Flurl again to communicate with their servers. So let's just pick one. I mean, there's a login, you get back a token, and with that token you can then access their services. You can refresh the token, so it's an OAuth flow that we have here. Just an example what we have here. Yeah, let's just take this one. Get vehicle async, that's what I named it. So they have got a base URL, and that base URL is you can see it. It's owner.api.teslamotors.com. It's interesting if you know a bit about Tesla. In the beginning they were called Tesla Motors. Later they were renamed to just Tesla. So the website is now at tesla.com, but the API is still at teslamotors.com. So that's what the base is, and from there you can just append all the path, and here you can get information about a specific vehicle. So that's API/1 vehicles, and then the ID of the vehicle. So RESTful API here, send the token, and you get back a long piece of JSON and I generated some DTOs here that contain the information that is in there. So things that would be returned are the vehicle identification number, the name of the vehicle. Every vehicle can be named. I don't know what the status is. I haven't really checked it, whether it's currently in service or not. And there are other methods that allow us to retrieve things like the state of charge, and even there's a streaming API that even tells you what is the current speed that it's driving at and where is it heading and things like that. So that's a project that I was working on previously, and what I did here, I just brought in that C# project. So there's the Tesla API, it's a .NET Standard library, and I'm using that from within the EV source here. So that's what I did over the week, but it's not fully functional yet. And like I said, I cannot demo it really. I was thinking about adding a mock layer, but I mean, just to show that this is returning JSON, it's not super interesting. So I'm just added it. It's going to be checked in. You can have a look at it. There are no secrets in there, and I don't want to run it because that means I would have to provide all these values, and the chances are just that I hover here or it fails somewhere and hits a breakpoint, I don't know, and then in the debugger you could see all these secrets, which is a bad thing. So if you own a Tesla and you always wanted to see if you can access it over the internet, well, after this episode of the stream, I will have this checked in, and then you can use these methods and have your own little .NET console project and communicate with the car. Okay, so that's this one. That's one thing that I added. What else? So I did the walkthrough, the containers. Right, so I wonder if we're going to do a lot of programming today. So I wanted do a bit of research and setup, and I thought let's have a look at the Azure Portal. Yeah, that was the idea, because what I need here is this function that that reads the information from the sources, kind of aggregates everything together. It has to not only write the results into a history table, it also has to know what are the actual sources that it should call. So my idea was that I would have some sort of registry, and that would contain like the information, what is this source about, like getting info from the car. Every source has got an endpoint that would be stored in there. It has got an interval at which the source would get pulled, and maybe it would contain information when was the last update. And the function would just read that, and if you add something in here or remove something dynamically, then it would add that source or it would exclude it. And when I did this, I originally thought, well, that looks like relational database, more or less. It's rows in a table. But then again, I'm not sure if I really want this. Do I want to introduce SQL Server just to store that? No, certainly not. What are my options then? So I wanted to explore that a bit and see what we have here in the portal. So here in Azure Portal, I'm logged in already, and I'm looking at my dashboard resource group that I have created. And I think we're gonna start by adding a storage account, because go back there, here. The storage account I will need that. I will certainly need that because I want to store all the retrieved values kind of in a history table. And I was thinking Cosmos DB table APIs there. That made most sense to me because they are cheap. I don't have very semi-structured data. So Cosmos DB table API, that I think makes sense to me. I'm going to use that, and I'm thinking maybe have just another table that acts as the registry. Why not? Let's go there, see what we have. We want to have storage. Select that here. Wow, there's a lot. There's a lot. And Azure Data Box, that's so not what I want. I just want the most obvious one, Azure Storage. searching. Aha. Can we just do this the traditional way? Create a resource over here. And then the web apps, serverless. Yeah, we're gonna need that too. Oh, hang on. So I probably want to create a Cosmos DB, and that involves creating a storage account. Maybe that's even easier. Account name, API, Azure table. But how would I create it? How would I don't get that. Yes, discard. Storage account. There it is. That's what I was looking for. Let's create a storage account. Okay, so that goes into my enterprise subscription. That goes into the dashboard resource group. The storage account name, that would be dashboard storage. Only contain lowercase. It's already taken. Then let's prefix this with my initials. Yay. Dashboard storage. Let's put this to West Europe, I suppose. And performance standard, general purpose. I just read about that, and I was wondering, why did they still, I should say, why are we still offering that, being employee Microsoft? So general purpose V1 is the old one, and blob storage alone is even older. So why do we still have these? And general purpose V1, there are cases where it's just cheaper. It doesn't have all the features, but if you don't need these features, then you can still go with purpose V1. Now, please don't ask me what these features would be. Let's just go with V2 here. Replication. We need geo-redundant. No, I don't need geo-redundance. Locally redundant. The most basic one. Access tier. Cool hot. And that. So will there any blob? So this is only used by blobs. I don't care about blobs. Let's just set this to cool. Advanced. We need secure transfer required. Yes, please. This should only work over HTTPS. All networks. Yes. That is something that I could change later. So really, this only needs to be accessible from the Azure Functions API project, or from the locally running Raspberry. So I may want to change this. Blob soft delete, no tags, review and create. Let's see. I hope this doesn't take too long. So while this is generating the account here, why don't I go ahead and merge the changes, the source that I added, merge that into the main branch. What did I change there? Oh, so I renamed that. Good. Just see, I added those. Let's go ahead and say we want to add EV source not completely done. And we probably want to merge this in. Merge into current, merge into master, temp EV. Yup. And let's push that. What's this? Wow, it's done. Go to resource. Good. Let's just double check. What are you doing, GitHub? There we go. Let's see. So that's here. Good. So that means if you would like to, you can have a look at the, well, how to talk to the Tesla API that's now live there. Oops. Okay, so back there, we've got a storage account. Good. Now within that storage account, open an Explorer. What Explorer? Ah, Azure Storage. Yeah, right. So in order to browse the content of a storage account, we can either use the portal, we can of course use the CLI or .NET SDKs, or the Storage Explorer. I showed that in other episodes of my stream, so there it is, the Azure Storage Explorer. So let's see, can I open that from here? Open Storage Explorer, it's already open. And the subscription is filtered out. Why is that? Why is that filtered out? I don't get it. Visual Studio Enterprise. It's not filtered out unless subscription, Visual Studio Enterprise. Visual Studio Enterprise, apply. Can I refresh that? Doesn't make sense what it's showing here. There it is, dashboard storage. Nothing in there. Good. Well, let's go back there. And what we need is now a table. So can I add that directly in here? Blob service, file service, tables. There we go. You don't have any tables yet. What happens if I... Okay, this is interesting. Let me just create one, test table. So what is it creating here now? Because I wonder, because if I look at this here, Azure Table Storage Overview, that's really what I'm after. And this content applies to the original Azure Table Storage. There's now a new premium offer for table storage, the Cosmos DB Table API. So what I create here, is that now the old one, the legacy one, or is it the new one? I have no idea. So I should be able to find that out if I go here, create a resource, and we want to go for storage, and no, where was it? Just search for Cosmos DB, create. Dashboard. I don't get that. How do I tell it that it should go into this storage account? API, Azure Table. Dashboard. Tables. Location, Europe, West Europe. Geo redundancy. Disable, I don't need any of these. Next. Choose the API. Yep. No. Let's just see what it creates. Dun, dun, dun. Open this second one, a new tab here. And we look at the, I want to go back to what has just been created. Dashboard storage. So that's the one that I created. I'm running out of credit. Bummer. And in there was table service. But there's no whatsoever indication that that would be an older version of something or access policy. Let's just see what it's creating here. What if we just Google that? Cosmos DB table API versus Azure Storage Tables. That is very similar to Azure Storage Tables. Let's see what it says. Document store, wide column store, key value. Both are schema free. I was thinking that really the only way of having a table storage would be via Cosmos DB these days, but apparently I was wrong. Yeah, it has all these nice features. I reckon that the older table storage, or the Azure, what is it called? Azure Storage Tables, it's just a lot cheaper. But, Let's just see what it generates, because I wonder if it's going to create another storage account now, or is the storage account not needed at all? Let me just double check. What does it say here? Storage account. Cloud storage that is highly available, secure, blah, blah, blah. Storage includes blobs and tables. I see. So then I misunderstood that. I thought that Cosmos DB was actually part or somehow a child element of that storage. But that's apparently not the case. I actually wonder. I gotta double check that. Coincidentally, I'm writing in some document, and I thought I found exactly that reference somewhere in the documentation that said that Cosmos DB belonged to Azure Storage. Let me double check. Cosmos DB tables versus storage account. Let me take a note. Okay. So maybe I don't want Cosmos DB then. Let's see, what are the differences? Table API 10 fields, blah blah blah, 10 seconds. With table, empty tables cost money. Query results returned by the table aren't sorted in partition or row key order as they are. Batches can only have course isn't supported. Table names. Some internal forms found table. Not atom. It's always these decisions that one has to make, right? So do I need this? Maybe not. Maybe I should just go with the storage tables. I mean, they are super basic. Oh, what? I'm gonna cancel that here. The APIs, they are compatible anyway. So even if we find later that, well, that was a bad decision, it doesn't quite work, it should be easy to switch over. So let's see. That means we need to go there to the storage and go back to the tables. Where are they? Table service. I don't want the test table. Delete. Yes. What we need is a table that is our, well, just history. And I'm gonna need, yeah, you deleted everything, thank you. I need another table that is registry. Source registry. There we go. So what can one do now with these? Can I edit them from here? Storage Explorer, yeah, we have that open. So if I refresh here, I should be able to see those. And tables, yeah, there they are. So I can edit them conveniently here on my client. And let's just see, what can we do here? Query, import, export, add. How can I add something? There we go. They also need a partition key. They need a row key. I don't have a partition key. It's just a registry. What is my, oh, are they limited to string and I need more add property? I need, so I want to see what can I put in there. What did I have in mind? Let's go back there. Dashboard. I would need a URL. That's the source URL. Okay, so they are always there. Partition key, row key are always there. We get a string here. We would need an interval. That interval is probably going to be seconds. Let's just make this an integer. Enter a signed 32-bit integer. I don't want to enter anything. 0. Add a property. What's the other thing? Last update. Maybe a date time. I don't want that. I just want that to be null. Let's see. And maybe some sort of identifier or name. And finally, it's going to be an enabled. True, last update. What do I know? I don't really know what I'm doing here. Last update. What is it? What do you want me to enter? Enter an ISO date time. Can we just skip that for now? I just want to see what happens. Insert. Add entity. You know, I'm a bit puzzled by this because I only work with Cosmos DB, and I mean in Cosmos DB what you get back is it's JSON, right? You can query that using SQL. So I don't really know what I'm looking at here. It appears to be like a SQL, like a relational database, but it's not. Just the columns, we want to display them in the table. And table statistics. What can I query here? So what is that? I thought that was really just a dump key value storage. So where is that? Where is that documentation I had there? Is that the one? No. This one here. What is table storage? Large amounts of structured data. Is a NoSQL authentic? Yeah, cool. Storing data sets, complex joins. An entity is a set of properties similar to database row. An entity in 1 megabyte. Property name. Okay, so that's, of course, that's convenient if I can handle it like that. Where's the documentation? Where does it say something about the data types there? It's mainly looking for a way to specify the date. Table storage concepts. Create an account. Understanding the table service data model. Yep, understanding makes always sense. Tables, entities, and properties. Partition key. Yeah, so partition key is, I mean, it's probably similar to what or exactly the same as we know it from Cosmos DB. But I don't really have to care about load balancing because this is going to contain what, like 3 or 4 entries. Partition is a range of entities, the same partition key value. You must include. I must include. Okay. The row key, unique identifier, partition key, unique identifier. Yeah. I must include timestamp, property types, date time. Oh well. So can I edit that? And delete tables? No. Oh, I did this in here. Edit column options. We want to go there. I can change them apparently. You know, on the one hand, it's a bit convenient, but on the other hand, it's limiting. Edit. What can I edit? Ah, there I can edit. Great. It seems like this is exactly the ISO format that I was looking for. Let's just copy that here. Let's add one. Last update. I'm gonna call it last update UTC. That's a date time. Add an entity like that. Enabled interval partition key. And there was one more thing that I needed. Didn't I add a name in there? I thought I did. Name. But that's it, right? Those are the ones I wanted. Dashboard. So some name, a URL, the interval in seconds, the last update, and enabled, which is not there. There you go. So that would be interval seconds. Update. So what happened to my oh my god, I'm so lost here. What happened to my other data? There it is. Timestamp, enable, last update. Where's the URL? What am I missing here? What am I missing here? Edit. Add a property. I know I added a URL. Update. So now it's enabled, seconds, name, URL. They're all there. Okay, so let's, can I edit that in here? I can't. Oh, now I get it. Now I get it. I've been using SQL, what is it called? SQL Server Studio, the client too long. Yep. So I can do whatever I want in here. It's not defining a schema or anything. It's just creating an object that has these properties, but I could have another entity with completely different properties. So it doesn't limit it. Okay, I think now I get it. So if I edit, I'm editing that particular entry here, not the schema or anything. Good, and that's why it wants these values. No, it all makes sense. So let's try this out. What do we need here? So that would be the source for the solar panel. How often would I want to update that? I don't know. Maybe every minute. That would be 60 seconds here. Last update, I don't care. That would be solar, and the URL. Well, I don't know what that's going to be. HTTPS, and then we need. Well, whatever. I'm just gonna save this in there. So that's what my registry is gonna look like, and this will be read by a function that we don't have yet. Yeah, slowly it's making sense now. Okay, good. So what did we learn? No need for Cosmos DB here, because it's enough. It's cheaper. For Cosmos DB, you have to pay even if you don't use the capacity. But I don't expect a lot of traffic, so I'm trying to be cheap here. So that's what I want to use. Good. Then we need something else in there. Let's go home, dashboard. So in my dashboard resource group, we should have that storage. What is this? Didn't I cancel that? Why did oh my god, dashboard tables. Where did you come from? That's Cosmos DB table. Oh god. Queues. So what do we have there? Storage. Tables. There, Cosmos DB accounts. It seems it has completed the deployment. Yeah, but I'm gonna delete that because, like I said, we're probably not gonna use that. Really, no need. So I'm gonna delete this here. Delete. Type yes. I still remember when they introduced the checkboxes here, so you could delete multiple entries. I immediately used that to delete my entire website together with all of its data. I was so hyped by the fact that I didn't have to click all of the test projects that I created, that I just selected everything and really deleted the entire website. It was pretty fast. The entire deletion process. So what do we need here? We need, inside that dashboard, we need something to deploy the functions app to. So just search for functions, function app, yep. Because currently this is only running locally. Let's create that. That would be rr dashboard functions. Resource group, use an existing, put that under dashboard. Yep, this one. OS. You see, that's also funny. I mean, functions are serverless. They are as serverless as it can get. Now, still, if you choose to run this on Linux, you can publish a Docker image. So I can create a Docker image that contains the functions runtime and deploy that to the cloud and run it as a function, although it really is a container. I mean, I like it if you have all these possibilities, but sometimes I wonder, why would you want to do that? And maybe reasons. Consumption plan, location is good. We want West Europe here. Runtime stack, .NET Core. Yep. Storage. Now that's interesting. A function needs a storage. Now I wonder if I can pick the one that I have. Yep. So you can either let it create one, or just use the one that is there. So what is it storing there? I think it's using the blobs feature of this storage. It's gonna keep track in there. What has it executed and what is currently running? All of the state is stored in there. Application insights is enabled. Good. Now let's create that. Deployment in process. What is it doing there? Deleted deployment, deployment cancelled, dismissal. Okay. And we have, why are they still there? There's the functions. Why are those tables still there? Didn't I just delete them? Failed to refresh. Yeah, did. Delete account. Confirm the account name. Oops. Failed to delete. because it's already deleted? Maybe it will fix itself later. Maybe it's just not refreshed. Let's see. No. Well, let's just hope that it go away. Good. So now we have got our functions there. They have been deployed, or the project has been generated. And it's already there, but I mean, nothing's happening if I go there. Your function is up and running. Great. It has got a connection to the storage, and I should be able to deploy the functions project now there. The solution has been modified. Yes, reload. So let's give this a try. Reload again. Keep on reloading. So like I said, not a lot of coding going on to there, just setting up the infrastructure, thinking about what is needed. And I was wondering if I'm gonna need a local storage account. So with the Storage Explorer, you can see there it also says local and attached. You can have locally running tables or locally running Cosmos DB instances. You can of course run the functions locally. So I wonder if I need this local setup or if I just let it always talk to the one in the cloud. I mean, it's a private project. Maybe I'm just gonna use the cloud-based one. The only thing is, if I go back here, no, not there. Oh, that, by the way, is the unofficial Tesla JSON API documentation. So like I said, if you fire up Google or Bing, you're gonna find that on the web. Not a big secret. That's what I wanted. Well, I wanted to go there. So where was I? The only thing that, or the only reason why I would consider a local version is because of the timer trigger. So that timer trigger would read the registry, and the registry would return the URLs, and the URLs would then be the ones in the cloud, but not the ones to my local instance of the function. So it would be easier to test if I had a local replica. So maybe I should. But before we get there, we would need these this durable function anyway. Maybe that's what we're going to do next. So we have got that table storage there. We've got this table storage there. We could replicate that locally and containers, and then go ahead and add that function. Tables, let me see, any tables here? No table, oops, there are tables. Ah, yeah, so this is interesting. I mentioned this before, and we saw it that when creating a functions project, it required a storage. And here you can see how it's creating tables in there. So there's durable functions, hub history, or whatever it is, hub instances. So here it keeps track of everything that is going on with the functions. That's why it needs that. Let's go ahead and create something in here. Or do I? Yes, I think I want. So let's just create that and create a table, source registry, and create another table, which would be the history. So now I've got a replica of what is currently in the cloud, and I'm pretty sure I can export what I have there. just go for the source registry. Export. What is it exporting? Desktop. Save, and now I can go here and try to import that locally, just so that I have one item in there that I can use as a starting point. Boom, there we are. So it imported that, and I'm running this locally now. Cool. Now back to Visual Studio. We need a new function in here. We need one function to call all the other functions. And I was thinking a durable function. Let's give this a try. Durable functions are relatively new. And a new Azure function. Yep, that one. And that would be the trigger, or the aggregator. And what do we have here? HTTP, timer, queue, blob, event, durable functions orchestration. I gotta check something. So as far as I remember, with durable functions, let me check something. It's not necessarily what I want. The idea of durable functions is that you have got longer running pieces of code. You still want to be serverless, and you want to orchestrate, like call this one, and when it's done, run the next one, or run these two in parallel, something like that. But then all of the functions or all of the code that you're running has to be within the within the scope of that durable function. So in other words, I would not be able to run the functions that I have already created here. They are a separate thing. So, but I gotta double check that. Azure durable functions. Let's see if we can have docs. There we are. Function chaining. Yeah, so that's one of the use cases of durable functions, like I just explained. You're gonna call this and wait for the other one. I don't really care about that. I just want to run, pull all of the sources more or less. So I don't want that here. Do I want fan out, fan in? So do I want to call something, wait for all to finish? Aggregate them, maybe. With normal functions, you can fan out by having the function send mode to the queue. Fanning back in is much more challenging. So what I really want is, if I go back here, what I really want is, I just want all of these puppies here in the registry to be called and pick up the returned JSON. Let me think about that. Look at the chat. Hi, I'm 19, don't know if I want to study computer science, become an electrician. Would you recommend a career in software development? Yes, I absolutely would. But, you know, being an electrician is certainly very interesting. And always when some renovation is done here at our house and the electrician is coming by and fixes things, I'm super impressed, because it's like, I would have no idea with all these switches and cables, and you got 3 switches for 2 lights, and every switch should trigger everything. I just don't get it. So it's probably more manual work, I should say, if I see what they are doing to the walls to get their cables in there. But I'd say with as a software developer, software engineer, there's more interesting stuff out there. There's just more things that you can do, and there's always something new to discover. So yeah, I'd absolutely recommend looking at computer science. I mean, the easiest way to figure out if that's something for you is just try to program something. I mean, there's plenty of examples. My son, for example, he's got this Lego robot, and he's doing some very basic programming there, and he loves it. So I think he's gonna do some coding later in his life. And there are other online schools that teach you coding, basic coding, so you could easily figure out if that's something that you want to do, and if you feel like that's fun, then go for it. Now back to this here, durable functions. There's an example. So there's an orchestrator, call activity async. Long-running operations with external clients. That's a bit what I want here. Simplify to interact with long-running functions. The durable functions, gotta have a look at the clock. I'm gotta leave on time today, but we still got some minutes left. Rest command, start an orchestrator. Request.content. The function name comes from the request URL. What? The function name comes from the request URL. Okay, so this is what? Running another function. Client starter, monitor. Human interaction. I'm not sure if aggregating over, no, not event. So the question is, can I call Azure durable function call other? I think it's not really about calling another function. Maybe the way I'm looking at this is wrong. If I go back in Visual Studio, so these functions here that I created, the source EV, the source Solar, they are really just URLs that return something. So I would have two options now. Have one durable function and include the code that is now separate, and the source EV and the source Solar and so on, include that as kind of methods into the durable function. Then I could have these long-running tasks in there, but I don't want that because I want to keep the sources separate. So it seems like I don't even have to be aware of that they are functions. I just have to know that, well, there's an endpoint that I want to call with my durable function. And that is supported, right? Call URL. Well, let's just create it. Let's just create it and see. Is there any changes? No, let's create a branch here. New branch. That will be aggregator function. Let's just see. Create a branch so we can go back. Okay. waiting. There we are. Okay, so it's creating, or it has created, the aggregator. That's the function that I told it. We've got run orchestrator. Okay, so this is where everything starts. Then context call activity async. So here I can call a function name. Yeah, so that's what I was talking about. Here it's calling other functions, and those functions are part of the same class. So I would not be able to call a function that is in there. And I don't want that, because to me a source can really be anything. It doesn't have to be one of these functions. So what can it do? Context. Call activity suborchestrator. I have no idea. You gotta read the documentation sometimes, right? Azure durable function get data from URL. HTTP APIs in durable functions. That sounds promising. Let's see. Fetch the status, send an event, terminate. Start new async. These operations are directly using the instance management. Instance management. Okay, let's see there. Is that what I'm after? Query instance. Not really. Durable orchestration client. Do I have that here? Orchestration trigger. It's funny, if you're looking at something, you really have no idea what you're doing. Here's the thing, I would be able to implement that using the traditional function just fine. It would be up and running in, I don't know, maybe about 10 minutes. But I mean, this is not just about getting the project done. This is also a process for me to learn about new things. And I feel like there's something there in durable functions that is probably useful. And this is, I think this is, it's something that every developer develops after a while. It's this smell that says there's something there. I just gotta find it. I know that I could solve it quickly, but it's probably not the right way of doing it. It would maybe work, but I would always have this feeling of I missed out on something here. So I need to figure that out, and I don't think we're gonna find the answer here within the next 5 minutes that are still left. Fan in, fan out. It's possible when you call for latency. Yeah, that's what I want. A function. Human interaction. Chaining. Nope. I gotta search for that. I know I'm going to find something, but I'm not going to find this now. So that means that's my task for maybe the weekend, to find that out. And then we should have an idea for how to implement that on next Thursday. So wrapping up today, what did we learn? We learned that Tesla apparently has got a web API that we can use, JSON-based one, which is great. I don't want to reveal my secret credentials here. We learned about durable functions, that they are, well, a variation and extension of the regular functions, because the regular functions, they have got some limitations, like they can time out, and we want to avoid this. We want to orchestrate multiple things, so we're going to use the durable functions, very likely. We learned about how to conveniently manage containers directly in Visual Studio, just by right-clicking, add container support. And over in the portal, we learned that Cosmos DB is not part of Azure Storage, as I assumed incorrectly, but instead both Cosmos DB and the storage account, they both offer a tables API, and we went with the storage account one because it's just doing the trick for us and it's cheaper. With that, I think I should be able to add if I get the durable function running, to make it regularly call the sources. I should be able to write that to the history, and that really doesn't leave a lot to be done. So it could well be that the next week or the week after, we'd already be looking at deploying the whole thing to Azure and see how we can create and update a static website. More interesting things to come, things that I have not worked with before. So if you want to join me on this discovery journey, you're more than welcome. I don't know about the time yet, could be next Thursday in the afternoon again, maybe even later. Playing a bit with the timings to see what the attendance is. But it'll be announced here on Twitch. So until then, thanks for attending, everybody, and see you next week.